Okay, in this video and the next video, I want to give you a little more practice with using z-scores, converting and finding the probability associated with the z-score and vice versa. In this first example, we have a Labor Day 5K race that is run for charity. Organizers know from past years that the mean time it takes runners to complete the race, the course is about 35 minutes with a standard deviation of 8 minutes. The race this year has 150 people who have registered. So we're going to be using this formula, our good old standard z-score formula. Now I've identified from our problem, mu, the mean time, was 35 minutes, so I'm writing that down, and our standard deviation was 8. I'm going to plug each of those items into the z-score formula. Now I really want to point out, be careful and make sure that your mu is always second. The x is the number from your word problem that you're going to be plugging in. Okay, so for this first one, a z-score for a runner finishing in 32 minutes and the probability that a randomly selected runner will finish in 32 minutes. So we're going to calculate using our z-score formula. Again, 32 is from our problem. It's the x value from our problem that goes in there first, then our mu. So we subtract and divide by 8, we come up with a negative 37.375, which we're going to round up to negative 38 just because your z-chart only calculates and uses z-scores to 2 decimal places. Oops, sorry about that. I'm going to go ahead and do that right now and show you the z table. Here's our z table. This was a negative 0.38 is what we rounded it to, so I'm on the negative side here. I go down here in negative 3. The tenths place is down here, negative 0.3. I lost my 8, but I want to go over here, roll up and see that, yeah, the 0.08 was the second to the last column. So that second to the last column and the fourth up from the bottom here intersect at 0.3520. So I wanted you to see where I got that. Okay, I also want you to draw the curve. It helps you to visualize things so much better. I like to see students do the data on the outside. You can do on the lower horizontal, I want you to do your z-scores, and then your shading is going to be that probability in between. You've got a lot of numbers that you're indicating on here, and if you just kind of get a pattern, it kind of keeps you organized, because it's very easy to get your numbers confused and not remember, is this a z-score, is this a probability, or what the heck is this? So part B, we are to find the z-score for a runner finishing in 42 minutes. And the probability that a random selected runner will finish in 42 minutes. We've got our z-score formula here. My x value for my problem was 42, so that's going in first. When I subtract, divide by 8, I come up with 0.875. Again, I'm going to round that up to the 0.88. I can go to my z table, and this time I need to go over to the positive side. I'm looking at 0.88. So my tenths place is 0.8. My hundredths place is also 0.8, or 0.08. So I have 0.8136. So I wanted you to see where I got that probability. So again, I've got my data values on the upper side of the curve. I've got my z-scores on the lower horizontal edge, and I'm putting my probabilities in between. So basically this means about 81% of the runners finished before this runner. So I've got this question over here to the side. Which is the better z-score if you are a competitive runner? I think when you look at the chart here, you know, you might be a little bit drawn. If you're struggling with understanding what all this is, you might be drawn to, hey, this higher is better, right? Not so much. If you are a competitive runner, you want to finish this. You want few people to finish this before you. So in this case, we had 35% of the runners, a little more than 35%, finished before the runner in Part A, whereas 88% of the runners, 81.06% of the runners on our Part B runner finished before our Part B runner, and that wouldn't be very good. That'd be me walking. This guy up here, who very few people finished before him, or fewer people finished before him, has the much better z-score. So this is a scenario where a negative z-score is better than a positive one. And a more negative would be even better. So a lot of times students get that confused. In our example where we had the I believe it was the bone density scan. A negative z-score in that scenario was not a healthy thing. You would have wanted to have a positive z-score and a higher one at that. So you have to understand your application to when you're making that interpretation. Okay, in our next part here, we're going to do some between problems. Okay, we want to find the probability that a randomly selected runner finishes between 19 and 51 minutes. So I have a real prescribed way that I want you to go about this. I'd like you to set up your z-scores one on top of the other, and I want you to work your way across each of these, but I want you to do the rightmost or the highest data value first. So I'm going to calculate the z-score for the person who ran in 51 minutes, calculate that, and then I'm going to calculate the z-score for the person who ran it in 19 minutes second. The reason I'm doing that is I have my higher one first, my most positive z-score first. That, when I calculate that and look that up in the chart, I'm not going to open up the chart and show you that because it's going to take time away from the rest of the video here. But you can look for that on the chart, and it will find that the z-score that is, or the probability that is associated with the z-score of 2.00 is 0.9772. The z-score that is associated, the probability that is associated with the z-score of -2 is 0.0228. When I find the difference between those two, see, they're now automatically stacked the way that you need them. I come up with 95.44%. And that truly makes sense for us because we've learned in our empirical rule, or we know in our range rule of thumb, about 95% of our data values will fall between 2 standard deviations below and 2 standard deviations above the mu, which is what our z-score of -2 and +2 represent. So basically about 95% of the runners will complete between 19 and 51 minutes. Okay, now we're going to look at the probability that a randomly selected runner finishes between 27 and 43 minutes. And again, I'm going to do the higher data value first. I plugged that in, subtracted and divided by 8, and came up with a z-score of 1. I did my lower one second. I plugged that in, divided by 8, come up with -1. I find each of these probabilities that relate and correlate to a z-score of 1 and -1. Again, I used the chart, the table, to do that. I have it stacked here so I can naturally quickly find the difference here. It came out to be 0.6826, and again, that makes sense. About 68% of the runners will finish between 27 and 41 minutes. In other words, about 68% of our data fell between 1 standard deviation below the mean and 1 standard deviation above the mean. So that all jives. Okay, and we also got a chance to practice the between and set up a good structure so we stay organized. Okay, so the last thing we need to do is how many runners are predicted to complete the race between 19 and 51 minutes. Well, between 19 and 51 minutes is from part C here. Well, we calculated that probability to be about 95%. So I'm going to take 150 times 0.9544 to find that we should have about 143 runners. Finding the number of runners between 27 and 43, that was from part D. We had the probability of 0.6826. When I multiply that out, I get 102 runners. Now, those that finish in less than 19 minutes, well, 19 minutes, I'm going to steal it from up here. We calculated the z-score that correlated to 19 minutes. That happened to be this z-score here, which is -2, which was this probability, 0.0228. I don't have to recalculate everything. I've got that here, and I find that about 3 runners will finish with a z-score less than -2. In other words, in that lower 2.5% down here. Okay, the other thing that I want to show you is that this can all be done on StatCrunch. So I'm going to open up StatCrunch, and the very first problem that we did was looking at the runner with 32 minutes. So let's go ahead and take a peek at that. The way you do this in StatCrunch is you need to go to Stats, Calculators, and then down to Normal. Okay, I'm going to do that again. Okay, I'm going to go to Stat, Calculators, and down to Normal. Up until now, we've done Stat Calculators, we've done Binomial, and we've done Custom, but we're in the normal distribution, so it makes sense that we're going to go to Normal. Okay, when I open this up, I'll just see a couple things. This is all going to be default. It's defaulting to a mean of 0 and a standard deviation of 1. That is our standard normal deviation. And these numbers down here are our z-scores. So that totally makes sense for us. But what I need to do is I need to put in the information from our word problem. I'm going to put in a mean of, the mean was 35, I believe, and our standard deviation was 8. Okay, this down here, a lot of times students aren't quite sure. Do I put a z-score? What is it asking for? This is asking for the limit for the x values in our problem. And so part A, that first one that we did, we wanted to know the z-score for someone who was running and did this within 32 minutes, and we're basically looking at trying to find the probability that a randomly selected runner would finish in 32 minutes. So I'm going to put 32 here. That is our x value from our problem. And so this is going to go directly to giving us our probability. It did not give us our standard deviation, or our z-score. I'm going to come back and talk about this in a bit. I want to do a between problem now. I'll do one of our last problems, our between problems. We had stat down to normal, stat calculators down to normal. And this time I'm going to hit the between. I'm going to go up here and I'm going to put in my mean score of 35, my standard deviation of 8, and again I'm looking at my x values. The first one I had, we were trying to calculate between 19 and 51 minutes. So we're going to put in 19 and 51 to try to figure out what probability, what percent of our runners finished in 95 in between that time, and that is our 95. We could put whatever our values were. So much of this can be done on StatCrunch.